Hey there, let's talk about vectors and scalars. First we'll talk about the difference between vectors and scalars, and then list a few common vectors and scalars. Then we'll talk about position, displacement, and distance, difference between velocity and speed, and finally acceleration. A vector has magnitude and direction. A scalar has magnitude but no direction. Magnitude is just how much of something there is. So for example, velocity is a vector. It has a speed and a direction. Speed is just a scalar. So if I say I'm going 5 miles an hour, that's a speed. If I'm going 5 miles an hour to the east, that's a velocity. That's a vector. Common vectors and scalars. So common vectors, position, displacement, velocity, and acceleration. Those are vectors we'll talk about today. Some other vectors include force, momentum, torque, electric and magnetic fields. Scalars, like distance, speed, and acceleration. Notice I have acceleration on both of these lists. That's because there's not a special word for the vector acceleration. Also things like time, mass, energy, temperature, and pressure and volume. So, for example, when I talk about time, there's no east, west, north, or south to time. It's just time. Okay, same thing with mass. Position is a vector, and it relates to a chosen origin. So, for example, this position vector starts at the origin, and it goes to the point at x equals 4 meters, y equals 3 meters. Displacement is a vector that denotes change in position. So I need two position vectors, r1 and r2. Delta r is the change from r1 to r2. So r1 plus delta r equals r2. You need to have a beginning point and an end point to give the change in position. Position and displacement are vectors. Distance is the related scalar. It just gives the magnitude. It just tells how far. It doesn't give direction. So for example, if you told somebody you were going 3 meters in the northeast direction, that would be giving the position vector. If you just told somebody you were 3 meters away, that could be in any direction. That's the distance. If I'm following directions on a map, I'm really looking at a series of displacements. So for example, if I'm going north on Southwest Waldo Place for 1/10 of a mile, and then turning right or east onto Southwest Campus Way for 2/10 of a mile, I'm looking at a sequence of displacements. Velocity is a vector. It denotes speed and direction. So if we know how fast we're going along each of these displacements, we can figure out the time increment for each displacement and add them up to get the total time. The word acceleration is used for both a vector and scalar quantity. We don't have a special word for acceleration vector. In general, vectors have magnitude and direction, but scalars only have magnitude. Position is a vector that relates to the origin. Displacement is a vector that denotes change in position. Distance is a scalar that tells how far without giving direction. Velocity is a vector that denotes speed and direction. Speed is the magnitude of velocity. We use the same word for vector and scalar acceleration.